Again, the question here is what? Find the complex power absorbed by each passive component. So question number 1, find the complex power. Absorbed by each of these elements. This will be supplying the power, obviously. And the other question, question number 2, find the power factor for the source. What is that power factor? Something stuck there. Okay. Now, well, we know complex power is what? S equals V times I conjugate, if you have the RMS value. So if I know what the current is, I can make my life easy. So I decided to use nodal analysis. That'll give me the current. And actually, it makes just the math easier because you're not dividing. And we said, some people complain, like, I get confused if it's I1 minus I sub 2. The cheating way is you make them reverse direction. This way, they're both pointing in the same direction. So that helps you. There's always going to be a plus there. It will never be a minus. And since this one going this way in this direction, through that one is going this way, you make then I sub 3. Notice through this one here, reverse direction, you can make them any direction, but if you don't want a plus and minus, then you can reverse the direction of each one, alternate. And you'll see why we alternate the direction, because if you do KVL right here for this loop right there, we say what? Negative. I like to use negative for when you're entering the negative value. It really doesn't matter. Plus 18 times I sub 1 plus, you can combine these guys together, 18 plus J10. And what is the current coming down? Going this way. Bless you. Isn't that I sub 1 plus I sub 2? So by reversing the direction, you can make them addition instead of subtractions. It really doesn't make any difference if you make them pointing in that direction or this direction. You just have to know if they're both in the same direction, you're adding them. But if they're in reverse direction, one is going down, one is going up, you're going to subtract them. And if you clean that equation, what do we have? We have 24 angle 45 equals 18, that's 36. 36 plus 10J times I sub 1 plus 18 plus 10J times what? I sub 2. What about I sub 3? There's nothing. That's 0 I sub 3. That's equation number 1. Notice the equation is really straightforward. If you do this one here, this loop, again, I'm traveling this way. I had the direction of the current going this way. Let's go in that direction. 18 plus J10. What is the current coming down here? I'm going this way. I1 plus I sub 2. Now I'm going back up there. That's minus 5J. What is the current going up? I sub 2 plus I sub 3. And that's equal to 0. Again, let's clean that one. 18 plus 10J, I sub 1. Let's look at I sub 2. 18 plus 5J, I sub 2. And what about I sub 3? Is that negative 5J I sub 3? That's equal to 0, and that's equation number 2. And we need a third equation, then we'll have three equations by three unknowns. We'll do this one, 1,000 times I sub 3 minus 5j. What is the current going up? Is it I sub 3 plus I sub 2? Clean it. 0 I sub 1 minus 5j I sub 2 plus 1,000 minus 5j I sub 3 is equal to 0. And that's my third equation. Now the good news is on my TI-89 I can do these. And here we go. Clear the screen. F18 to clear. There's nothing on it. I gotta get out of this. Where's home to get out of it? Or diamond? Which one? Apps of home? Apps? Where's apps here? Apps. Thank you. Yep, right there. I have to go simultaneous equation. And that is, where is it? Right there. Simultaneous equations. I'll hit enter. They're going to ask me, I have a new one here. How big that equation? 3 equations by how many unknowns? 3 unknowns. And now let's put the values in. So the first one, 36 plus 10j. 36 plus 10j, that's I. That's the first value. The second value, 18 plus 10j. Parentheses, 18 plus 10i. The next value is 0. And the answer is 240 angle 45. Here we go. Parentheses, 240 angle 45. I forgot to check and see if I'm in degree mode or not. I think I am. Now we go to the second equation. 18 plus 10j. 18 plus 10i. 18 plus 5j. Uh-oh. 18 plus 5j. I forgot to put the I there because it says 23 there. I went back to it. Then the last one is negative 5j. Negative 5i. And the answer for that one is 0. And the last equation, 0. Negative 5i. 1,000 minus 5i. And what's the answer? 0. And now I've got to solve it. F5 I think to solve, right? F5. Solve, and here we got the answers. My answer, I'm in rectangular mode. I guess my calculator was in rectangular mode. So here are my answers. Let me draw my circuit first. Put it there, because once I get the answer, I'm ready to find the answers to each one. I don't want to keep coming back to that picture. So what the calculator gave me for I sub 1, this is I sub 1 here. This is I sub 2. This is I sub 3. What the calculator gave me for I sub 1, it's 5.9, I'll cheat here, plus 10.4j. I sub 2, negative 3.6 minus 12.7j. And I sub 3 is equal 0.06 minus 0.02j. That's good enough.
I do not have that.
Which one? Anyone get different answers?
What is it?
These are my answers.
6.
I got 0.063451 minus.
Yeah, I got the first two, and then.
Oh, that's, you're in J. I'm in angle. That could be.
Rectangular mode?
Yeah.
I mean,
I got
When
the.
you do
angles
these,
first.
like, no, you round it to one decimal
Yep.
place. Like, on the test, we should keep more. Like,
Well-
like, just because later on, like, you know, especially like on 47 for me, like I got some that were like 0 point, like, and then I had like 5 zeros and then something after that.
No,
Is that
no.
assuming just
Zero.
rounding error?
Yep.
Yeah. Okay.
Never mind.
it's
never
correct, yeah. Because I can
I
change
was in polar.
polar mode, yeah. I can change mine back to mode in polar, but that's in rectangular mode.
Yeah,
That's
I got
better
it.
because you got to do conjugate stuff, right?
Yep.
Yeah. Okay.
Well, even with that, it doesn't really matter. Because with the polar, the conjugate just change the angle from positive to negative or negative to positive.
Oh, that's it?
That's it.
Oh,
Yep.
okay.
So if you want to change this, by the way, to polar mode, just go to mode. And instead of rectangular here, go right there and switch to polar.
I just saw the 5.9 on the select.
And notice here, is that what you got?
Yeah.
In polar mode, this is equal 11.97, so that's roughly 12. 11.97, angle roughly 60 degrees. The other one is what, 13.2? You got 13.2 here. Angle negative 106. And for this one, I got 0.07 roughly, or 65, or 66. How about 066? Angle negative 16 degrees. Are these your answers? As I said before, there's nobody probably on this earth worse with calculators than me. I am the worst person to use calculators. I always push the wrong buttons. I can't see half the stuff on it. Once you have that, then we can find the current going through each one of these. I know what the current through this. What is that current? That's I sub 3, right? So you can use any one of them. That's 0.066 angle negative 16 degrees. If you want to find this current here, we know what that current. Add these two and switch the sign. Notice both of these going up. I define it coming down. Both, if you add 2 and 3 going up and multiply it by negative 1 to switch the sign. So let's see what that is. I gotta get out of this, home. I think I go to home, okay. Here we go. 12 angle 60 plus 13 point, oh, yeah, I did use parentheses, 13.2 angle, I thought I forgot to put the parentheses, negative 106
Did you say negative 60?
plus 60.
Okay.
I see I have two set of parentheses, extra one here. I can do this. So this current coming down, if you add the current going up, if you add 2 and 3 adding up, it's 3.3 times angle negative 44. But I got to multiply it by negative 1. So the current coming down is 3.3.
You added 1 and 2, not 2 and 3.
Oh, I added 1 and 2. Oh, let me try it again. Wait. That 1 and 2, that'll be this current. So I found that current to be what?
I remember those.
I know, but I had it here, and let me just make sure I get the right number. Is it 3.3? Which is 1 plus 2. 3.3 negative 44 degrees. I sub 3, that's 2 and 3 added, multiplied by minus 1. It's backward, the sign. So let's do that. 13.2 angle negative 106 plus 0.066 angle negative 16.
Did you do negative 106?
Negative 106, yep. So now you add these two here, 2 and 3, if you add them, is the current going up. I don't want the current going up, I want the one coming down. So you take that number, multiply it by negative 1. And I get 13.2 Can you see that 13.2? Does it look like 13.2? That current here coming down is 13.2 angle 74. Is that what you got? And what is this current? This is the sum of the three of them, KCL. All the current entering the node equals all the current leaving that node. So let's see what that number is. Just double check these numbers again. Don't trust me. Negative 44 plus 13.2 angle 74 plus 0.066 angle negative 16. So when you add all three of them, that gives me this current, just 12 angle roughly 60. .03 angle 59.7. So I'll say 60 is good. So now I get the current going through each one of them. I should be able to find what the complex power by each one. I wish I have still kept my notes from before, because I gave you a shortcut to finding the power through a resistor, through inductive load. Do you remember, if you know the current? I gave you a shortcut for them. I will put it on the screen, but check your notes.
What are you trying to find?
To find the complex power is V times I conjugate, right? Well, I don't want to find the voltage. I can, but I don't have to find it.
You can do I effective
Squared.
This is
times Z.
The magnitude of that, right?
Yeah.
Yep. The absolute value of that, yep. Which is the magnitude, you know. So you can find the complex power by this one. I'll derive it. It's straightforward. I don't know why I'm saying. I'll derive it again.
Do each individual.
We know complex power. I'll derive that equation. V effective, or RMS, whatever you want to call it, times IRMS conjugate. And if you use Ohm's law, I equals what?
V over R.
V over R. That will be VRMS times VRMS over Z conjugate, which you end up with what? VRMS conjugate over Z conjugate. So the magnitude of that, if you want to find the magnitude of that complex power, VRMS squared divided by Z conjugate. Well, I don't have the voltage here, But if I do the current here, S equals what? Again, V RMS. Well, V is I RMS times Z times I RMS conjugate. So you can get the complex power, which is what? I RMS times I RMS conjugate times Z. So if you look at these, you know the current going through each one. I don't have to find the voltage. So let me find, if you want to treat this as one, that's fine. You want to treat them as two separate things, that's fine. So for this one, complex power by that source here, I can use that equation because I know what these values are. Let me start from the right side. So complex power, S, I'm looking for the complex, not just the magnitude of that. It's I RMS times I RMS conjugate times Z, right? That's the equation just derived. So let's look at this one. What's the complex power absorbed or delivered to that 1,000 ohm? We know what that current is. 0.066 angle negative 16. My pen is dying. Do I have a backup one here of the same type? I have a lot of them. I just purchased some. No, but this will do the trick probably. Let me know if that works. Like, good enough. Times the conjugate of that, 0.066 angle 16. The conjugate, you change the sign. And you multiply that by the value of Z, which is what? 1,000. And what you're going to notice about the negative 16,
Is that angle?
that's angle, not times. It looks like a times here. I was more concerned about the pen. That negative 16, that plus 16, they cancel each other out. You'll see that. But if you put them in, you go 0.006 angle negative 16 times, I wrote it wrong. I told you not to trust me. 0.066, not 006. 0.066 angle negative 16 times 0.066 angle what? Positive 16 times the 1,000. And you end up with complex power has only real portion. It's a resistor. Does not have any reactive portion. Plus 0J. No imaginary. And again, the units for complex power, VA. The complex power absorbed or delivered to the negative 5J. We know what that one is, 13.2 angle 74 times the conjugate of that, 13.2 angle negative 74 times the impedance, which is negative 5J. And you will notice this will be a reactive portion, all of it. It's not going to have a real portion. You'll notice these guys mathematically will cancel each other out, but I'll leave the problem the way it is. 13.2 angle 74 times 13.2 angle negative 74 times negative 5J. And I should switch to rectangular mode, but I am in polar, it tells me negative 90 degrees. So negative 90 degrees, that means negative J, 0 minus 871.2 J, VA. There is no real portion. Let me change it back to rectangular, so the next set of answers. Negative 871.2J. You want to do the resistor separate than this one? Complex power, 18 ohm. The current through that, 3.3 angle negative 44 times 3.3 angle plus 44 times the 18. And that would be 3.3 squared times 18, actually. That's the magnitude, 3.3 squared times the 18. Quick math there. 196.02 plus 0J VA. The 10J. Again, we know the current through that. 3.3 angle negative 44. 3.3. What you're going to notice, actually, I'll go back to that equation. When you multiply these, because of this angle, they cancel each other out. You end up with 3.3 squared. That's what you end up with. So a lot of times when you look at that equation, you might see that equation written as IRMS, the magnitude of that squared times Z. Because that's what will happen when you multiply. The 44 and negative 44 will cancel each other out. You end up with 3.3 times 3.3, which is 3.3 squared times the 10J. Times 10J. So that's 0 plus 108.9J VA. And we have two more values, then we're done. Complex power, then we'll do the power factor. Uh-oh. There's two 18 ohms, so now we have to know which 18 ohm we're talking about. I'll just write top for this one. So let's look at the complex power for the 18 ohm on the top. I'll go on the next page just to leave some room here. So let's look at the complex power for that one. S for the 18 ohm on the top. The current is 12, so 12 squared, that's the magnitude of that, times the 18. Or 12 angle 60 times 12 angle negative 60. The plus 60 minus 60, they cancel, and up with 12 times 18. Which is 2592 plus 0J VA. And what about the source? Since you get the current entering the minus N, notice that current going up there. That's a negative. Again, the negative means we're going to supply power. That's what the minus sign tells you. VRMS times IRMS conjugate. VRMS is what? 240 angle 45 times RMS conjugate, that's 12 angle negative 60, the conjugate of that. So 240 angle 45, not 0, times 12 angle negative 60. And the source actually is going to supply, and I forgot to put the minus 1 to indicate supplying. I came up with an answer of negative 2781.87 plus 745.4 J VA. So now we found the complex power supplied or absorbed by each one. This one actually supplied power, the rest of them taken power. The second part of the question, can you tell me what the power factor of the source? Well, here's my source. That's part 2. Question 2, what is the power factor? Well, definition of power factor is cosine theta V minus theta I. What's theta V for the source? 45 minus, what's theta I? 60. That's equal to cosine, is that negative 15 degrees? Cosine, where'd you go? Blue, cosine, negative 15 degrees. Notice the angle is negative. See, the angle is negative? What does that mean, negative angle? Leading power factor. The power factor is 0.966 leading. How do we know it's leading? The angle is negative. If theta V minus theta I is bigger than 0, it's lagging. If theta V minus theta I, it's a negative value, like from negative 90 to 0, that's leading. I didn't say equal to 0, because if it's equal to 0, what happens? You're in phase. There's no leading, there's no lagging. If theta V minus theta I, if the angles are on top of each other, you don't have any leading or lagging. You have purely resistive load. So in this case, that's a leading power factor of 0.966. Any other questions on that homework?
Number 40, page 454.
40.
We've done everything that's going to be at the
Just D,
exam, right?
just the last D.
Yep.
I don't
Uh,
think
Let's look at number 40.
so. Yeah, he did.
A through C is just D.
Well, I probably have to do, I gotta see what the whole question first. Let me just see it. We got time for it. I'm just mad my markers are dead, my two. So I gotta use, let me just try a different one.
Do you, like, all the parts have nothing to do with each other?
No?
Yeah.
Let's see.
They're like, they'll be, say something like, the complex power is this, and the power factor is this. What's the complex power?
Okay, let's see what we have here.
D is weird though, because then you use like the power average.
Compute the complex power S in polar form drawn by a certain load if it's known, if it is known that, this is the load, this load draws 100 watts, that's average power, that's P. Power factor 0.75 and lagging. I was looking to see, yes, I almost said it doesn't say lagging or leading, but it does say lagging. I just missed it the first time. That's part A. It says, that's all we know. Can you tell me what the complex power? There's a load that draws that much. What is S equal to? That's part A. It's a multiple part question. So we'll just go through this quickly. If you know what that value, that's actually your what? Your real power. The fact your power factor is lagging, that tells me the angle is positive. So this is complex power. I know this value is 100 watts. I'm looking for S. I also know this angle. How do we know that angle? We know it's positive because it's lagging. It's the inverse cosine of 0.75. So what's the inverse cosine, second cosine, or third cosine on this one? Diamond cosine, 0.75. 41.4 degrees. Can I find what Q is?
Tangent.
Yep. Tangent 41.4 equals the side that's opposite, which is unknown to me, divided by the adjacent, which is 100. Take the tangent of 41. Tangent, where are you? Blue tangent. The tangent of 41 times 100, it's roughly what, 88.2? So the complex power S is going to be 100 plus J 88.2. That's part A. Now the second part has nothing to do with the first part. It says we have a load here. They're not telling us much about the load. They're saying here's what we know about the load. That it draws a current, there's a current going through it of I equals. So these numbers no longer here. I equals 9 plus 5J. RMS value. When connected to a voltage of 120 angle 32. The voltage here, 120 angle 32 volts RMS. They're looking for the complex power again. That's straightforward. Complex power is what? V times I conjugate. So 120 angle 32 times 9 minus 5J, the conjugate. (120) angle 32 times 9 minus 5J. And I came up with complex power 1, 2, 3, 4 roughly, I rounded, plus 63.5 J. That's part B. 2 more parts, this problem is over. Part C. Part C. Here's what we know about the load. Throws 100 watts and 10 var reactive of power factor is leading. Power factor, it says leading or lagging for that one? Leading. Different example again, that's C. What you know now is actually, since the power factor is leading, That means which quadrant? Down here.
Watts, actually.
Huh?
It's 1,000 watts, not 100.
1,000?
Yep.
And the other one 10 var?
Yep.
Okay.
We just go straight to complex.
Yep, it is complex. You already have everything. This is 1,000, and this is negative 10. Because it's negative down here. So the complex power will be 1,000 minus 10 JVA. Because of leading, that tells you the angle in this quadrant, negative value. So the imaginer has to be negative. That's really the whole point of this one. They're giving you the value to be 10, but the leading tells you is plus or minus. And now finally it's D. That's the one you were asking. I just hate to jump to a problem in the middle of it because sometimes I go, oh, maybe there's something I need from the previous one. Apparent power 450 with the power factor 0.65. Okay. So here what we know is the apparent power. Is that what we know? Yep. Apparent power. And lagging power factor. And find the complex power. Well, the apparent power, when we're talking about complex power, doesn't really come into the story. But I know the definition of power factor is what? One of the definition is what? The average power over the apparent power. That's one of the first definition of average power. Somewhere in our book, power factor. If I can find that before I get to complex. Where is power factor? Come on, somewhere here. I don't know which chapter. Can't remember. Oh, right there. Power factor. Average power over apparent power. So now you know your average power if you know the power factor. 0.65 equals what? Equals P average, which we don't know what that is, divided, was it 450 here? So the average power is 450 times 0.65. 450 times what? 0.65. 292.5, how about 293 watts? Now we can finish it. We know it's a lagging power factor, so the angle is positive. We know this value is 293. That's your average power. We know this angle is the inverse cosine of what? 0.65. So what's that angle? Inverse cosine of 0.65. I hit the wrong key. Inverse cosine of 0.65. 49.5 degrees. So I can say tangent 49.5 equals Q over 293. We can get what Q equal to. Tangent times 292.5, 342. So what's the complex power now? 293 plus J 342 VA. So by knowing the power factor and the apparent power, we manage actually to get the average power. And once you have the average power and the angle, you know what the complex power, that's your S right here. That's your Q. That's your P. Average power, reactive power, complex power. Bless you. Bless you. Okay. Any other ones?
I have one more last one though. Number 42. The second graph.
And 42. The second graph. For each of the triangle, determine S in polar form. Second graph.
Yeah.
You know what S is in rectangular mode. This one?
Yep.
S equals 1 plus 4J.
Yeah, I did that, but the book has different answer.
Yeah, you gotta change it to polar.
It's also in K.
Oh, that's in 1,000. Okay, so 1,000 plus 4,000, J. Right? So if you look at that picture,
But it says change to polar, what does that mean, just like the angle?
yeah, the other notation, rectangular versus polar. R angle theta is polar. So you have this, and looking at that picture for that one, that's a 4,000, if I'm seeing it correctly, and that's 1,000. So that's your S. So S equals 1,000 plus J 4,000. Now my calculator does that for me, but if I want to do this by hand, that would be the square root of 1,000 squared plus 4,000 squared. And the angle, to get the angle, it's the inverse tangent of this over this. Or I can just type in my calculator, go 1,000 plus 4,000J. And if I put my calculator in polar mode, or that's rectangular, I go mode, give me that in polar. Hit enter, and it says 4123. So if you do the math here, it's 4123 angle 76 degrees.
The book had 14 degrees. So that's why it wasn't true. Or the answer, the solution was.
Nope. And
Wait, what degrees?
he said
It
4.
had 4.123 angle 14.
Are you sure it's not for the first part?
No, it was the solution for the book.
No, I mean for part A.
No, it wasn't. I'm pretty sure.
No.
And the power factor was.
Was it negative 14?
No, because the angle in the first quadrant.
Well, I'm just saying, because
Yeah.
like if you shift it by 90, you
Yeah.
get negative 14.
I was looking to see if they define this angle theta, because if they ask for that angle with respect to this line, sometimes like they try to be like this angle, but no, the angle is always measured right here. This angle is 76, that's 14, you know.
Because then when we calculate for power factor, we get 0.24.
Power factor should be cosine the 76 degrees, that angle. Cosine, where's the cosine function? 76 degrees, 0.24. Is that what the power factor they're giving you?
The book gives 0.97.
That's the
I got
cosine.
0.24.
Yep. These are the solution in the back, the book. There's also, if you go to the end, the last page in that solution, there's a corrected page there, has corrected answers. So
Because I
check.
got what you got.
Yep.
So I was just
Yep.
not sure if I was doing something wrong or.
No, that was it.
Isn't power factor super small though?
Could be, yeah, because you're looking at your load here. It looks like all reactive. Look at this, 4,000. You know, your load is purely reactive almost. You're losing a lot of that energy. Notice you have, for every 5,000, you're getting 1 going to the real, 4,000 going to imaginary, the real. So you're losing 80% of that almost. And that math says that, yeah, you're losing a lot of it.
So it's lagging.
This one, yes, because the angle is positive. Yeah, I'm just looking at the unit to see if anything is marked, check marked on this, and I don't see it. But I think there's a page of solution, corrected solution to this one. It might be on the last page because I got it and I think I posted it there to some of these. Any other question before I shut the video?
What's the difference between apparent power and complex power?
Well, okay.